Hello, this is Yannis from Any Repair. Today we will go through a repair of a notebook, a XIAOMI 16 notebook, which came to us with not charging. The Type-C port is working in data transfer, but is not charging the node. Let's go see how we will treat with this. Here's the notebook. We have removed the lower case. We have removed the SSD drive. We have removed the CPU fan, it's not needed. And now we must plug the power supply, our Type-C charger, with our ammeter and check the voltage and the amperage that is drawing. We can see it requests 20 volts, that's okay, but no consumption. The Type-C port responds well, but when pressing the power button, we have no consumption. The computer is not powering on, as you can see. We're pressing the power button and no consumption happens. So it's not turning on. As we said before, the Type-C connector is responding to data transfer, but not to charging. So we must plug the multimeter and check for some voltages. We have already found the schematic diagram and the board view for this board. So we must go to our microscope view and check for the architecture and the voltages that are present. Let's go and see. Now we are in the microscope view and we can see there was a short here that blown up the capacitor that was connected. We are having 20 volts here. This rail connects to this IC that I think it's controlling. It's a load switch that is passing the voltage to the first and second MOSFET and to the current resistor. This is a DC in after this load switch. You can see the architecture. The current sensing resistor has nothing, and the first MOSFET is having 4.6 volts. So the load switch is passing only 4.6 volts and not 20 volts. You can see it. So we must go to the schematic and the board view to check about the input and the output and the requirements of the chip, because you can see we are having 20 volts here and 4.6 volts in the output. So with the help of the schematic and the board view, we will check for some possible causes for this fault. This is the schematic, this is the board view. Here is the blown capacitor over here. And here is the load switch and the filters. And below and a little to the left is the first and the second MOSFET and the current sensing resistor. Here is the load switch that is responsible to pass, as you can see in the schematic diagram, the 20 volts from the input to the output by taking some commands, of course. You can see the enable, and the ACOK pin that are controlling this with some voltage dividers. There is an architecture that controls this chip. And this is the data sheet that we must check before everything, because as you can see, there's a divider for overvoltage here, but as you can see, the ACOK and the enable commands are active low, so we must have no voltage on these pins in order for the chip to respond positively and pass from input to output the 20 volts. I think that the proper condition for the chip to work. Let's go and see what will happen there in the real time checking with the multimeter. Okay, the charger is plugged. Let me focus better. Okay, much better now. I have already scrubbed the pins. Nothing's changed. You can see 4.6 volts, and we have no voltage with the enable pin and almost no voltage in the ACOK pin. So I think that the conditions for the chip to work are met, but the chip is not responding properly and is not passing the 20 volts to the output. You can see we have low signal on the enable pin and low signal to the ACOK pin. And that is the reason for assuming that this chip is not working properly, because all conditions are met and the IC is not responding. Now, we will connect a wire. We will connect a wire in order to bypass this chip. We will let the cable, the wire, to do the load switching. So we will connect a wire from the input. We're trying to solder it in a proper way, not to rip any pad. Now we will cut it down here. Okay. And we will solder it on the filters that should have 20 volts if the IC was working properly. Add some flux and press it down, solder the wire on the filters. So we are ready. What we have done here is that we have bypassed the load switch, and with a jumper wire we have connected the input and the output of this IC. As you can see, with this resistant beeping mode, the bypass is done. So we must plug the charger. Okay, the charger is plugged. And check if we have 20 volts on the filters that are feeding the first MOSFET. In voltage mode, Let's go directly to the current sensing. And yes, we're having 20 volts on the current sensing resistor. That means that the MOSFET are okay. You can see the gates, 26 volts. There are N-channel MOSFET, so we're okay with this switching. And now we must check if something is changed on this notebook. Let's see if something is changed, if we have display. Okay, I will hold the board not to fall, and we have display. You can see the no bootable device. Let's force the notebook to shut down and power it on again from the power button. It is responding, no bootable device, we have display, and we are okay. Of course, we cannot leave this board with a wire doing the job of the switching. Of course, we have already ordered the IC that is probably faulty. So we must remove the old AC and replace it with a new one. This is the new one. We will first remove the cable that helped us diagnose the problem that we have already suspected. So with the tweezer and our soldering iron, we will remove gently the wire, and after that, with the use of the hot air, we will remove the IC that is faulty. Now it is the time for the IC to be removed by our heat gun. After we have cleaned a bit, hot air with a low air speed, and the IC will be removed. It is a BGA IC, as you can see. We will check for the alignment, although we already have the board view to help us, but this is a habit. After that, we will clean the old soldering alloy with the use of flux and wick and our soldering iron, just to be flat. We will wipe this old soldering alloy in order for the BGA pads to be flat and not a lot of solder remain on the pads, because the surface will be uneven and the alignment would be not the best for the small IC to be soldered. We will clean with isopropylic alcohol and a toothbrush. Okay, here is our new chip. After we will remove it from its plastic case, we will try to align it after, of course, adding flux. because no flux with soldering is not a good thought. The soldering balls seems to be okay. Now it's the time for the flux. And now it's the time for the alignment. You usually feel the BGA balls contacting the pads when you are pressing down the chip. But in that case, because the chip is very, very small, we will use only hot air in a very low speed, and we will see the alignment of the chip through the soldering alloy tension. You will see it jumping or auto align in its position. And the thing that we will make us sure about soldering is that when we will move it with our tweezer, it will go back on its place. We will go back and forth, or forth and back, and that will be the sign that is well soldered and that we are okay. You saw that I'm doing here. I'm poking it, and we are done here. Let's clean a bit with isopropylic and cotton pads or a toothbrush in order for the flux to be removed. And now we can try plugging in our charger and check if the load switch is switching. Because as you remember, the enable and the ACOK were active low, were low, so it should switch. Now we're plugging the charger. I will plug it better by pressing the board down because it's not screwed on the chassis. And it is time for our multimeter to reveal the truth. If the low switch is switching, and if we have on our system the 20 volts that we should have in order for this notebook to work. On the filters, we are having the 20.5 volts, so the load switch have switched and passed the 20 volts from the input to the output. And I think that the problem is solved. And now we will check if we are having display as we had before with a wire. Let me move some things away. This is my toothbrush. Okay. Moment of truth. I think we're having this display. But first I will press the power button in order to switch on. The amperage is high. And yes, no bootable device. The device is working. We are okay. That was the repair as you saw. If you liked this video, consider like, subscribe and share. Thanks for watching. See you in another repair.